Okay, everyone. Today lesson is about NCV level 3. We're going to solve these two examples using differentiation using first principle. So firstly, on our first example, we're going to solve as follow. We're going to factorize the numerator and factorize the denominator. So firstly, in order to factorize the numerator, we're going to say equals to lim x approach 1. To factorize this one, we're going to have x, then we're going to have x minus 1, x plus 1, all divided by, to factorize the denominator, we're going to have x minus 1, then x squared plus x plus 1. So secondly, to be able to see that you are factorizing are correct, when you open brackets must lead you here, and even this side when you open brackets it must lead you here. Then thirdly, we're going to have equals to lim x approach 1. Then as you can see, if we try to simplify, we're going to cancel x minus 1 and x minus 1 will cancel one another. Then in numerator, we're going to left with x plus 1. Then on denominator, we're going left with x squared plus x plus 1. Therefore, from here, secondly, wherever we see x, we're going to replace it by 1. So wherever we see x, we're going to replace it by 1. What we're going to have, we're no longer writing lim x approach 1. Wherever we see x, we replace it by 1. Where we're going to have 1 plus 1, then divide by this side, we're going to have 1 squared plus 1 plus 1. So if we try to simplify at the numerator, we're going to have 2. Then on denominator, we're going to have 3. So this is our final answer for example number 1. So let's go to example number 2. Then on example number 2 will be solved as follow. You must know the formula of first principle on your formula sheet is always given. So from here, we're going to say f prime of x equals to lim h approach 0. Then we're going to apply that formula. Our f is 1 minus 1 over 3 x plus h minus our f of x is 1 minus 1 over 3x all divided by h. So secondly, we're going to say equals to lim h approach 0. Always you must remember to write lim h approach 0 as long as this h and denominator is there, but we'll stop writing lim approach 0, lim h approach 0 when we read off this h. So secondly, we're going to open bracket. If we open bracket this side, we're going to have going to have 1 minus x divided by 3 minus 8 divided by 3. This side we're going to have minus 1, then plus, this side is the same as x divided by 3, because negative times negative is positive, it will be negative. Then just simplify, then we divide by h. Therefore, secondly, we're going to say lim h approach 0. Therefore, we're going to check for like terms. As you can see, negative x divided by 3 is a like term with x divided by 3. Which one? This is negative, this one is positive. This one will cancel one another. Then, as you can see, here we have a positive one, and here we have a negative one, and also this one will cancel one another. Then we're left with negative h divided by 3 divided by h. So to simplify this one is the same as negative h divided by 3 divided by h. Then when it is like this, we can simplify. That means we must change the sign. When we change the sign, we're going to have h divided by 3 multiplied by 1 divided by h. When the sign change, we multiply by the reciprocal of h. So from here, as you can see, when we multiply h and h will multiply 3. Therefore, if we do this thing here, we're going to have lim h approach 0. We apply this law here. That means we're going to have negative h, because 1 times h is h, negative h divided by 3 times h is 3h. As you can see now, h cancel h, then we're left with equals to negative 1 divided by 3. So normally where we see, if we had another h that left, that means whenever we're going to see h, we're going to replace it with 0. So unfortunately, there's no longer h. That means here is our final answer. Thank you.